Okay, so this is a doubt class, so let me take on the first doubt of the graph option. So let me first show you the schematic. Okay, see this circuit. Okay, this is the D flip-flop for which the graph you had a doubt about the graph of D flip-flop. So first let's see how a D flip-flop looks like. This is the D flip-flop. Okay, if you see this preset and clear dash, preset dash and clear dash. Okay, preset is nothing but set and clear is nothing but a reset, right? So if I give set is equal to 0 out here, okay, what will be the output? Is it dependent on D or clock? Enable, we are giving the clock here in that graph. Here if I see if I give a preset out here, okay, or set bar, if I give a 0 here, does Q immediately go to 0 or will it wait for any clock?
It would not wait for any clock.
Pardon?
It would not wait.
Yeah, right. Similarly, clear, right? Clear stands for reset. Whenever it goes low, so the preset and the clear are not dependent on the clock, right? So this is an it has got major role to play. It has got dominance over the other inputs. Okay, so understood this aspect. Now if I go to the graph, yeah, here if you see here the set bar is going low, so the output is going to slave to 1, right, irrespective of the D and clock, and after that the set is going back to high. Okay, here it is set bar, so here you will find it is an the set is disabled here because it is set bar here at 1. Now whatever is the next clock which is coming, it will slave as per D. Is that clear?
Okay, so sir, we are taking S bar and R dash as the S dash and R dash as the inputs here.
Yeah, that is generally we use those inputs to reset the if you have done that modulo 5 counter, right? We have done that, right?
Yeah.
When we reach that asynchronous one, so when you reach that particular condition, you will just you want to reset those flip-flops to whatever state, 0 1 or 1 1. So we use this R and S. You should not say it as an input. It's a control signal. Whenever you want to reset it to an either 0 and 1, we use that as an overriding control over clock and data. Okay, is that doubt clear?
Yeah, okay. Thank you, sir.
Okay. What's the next? What's the doubt?
Sir, so in lecture 17, in the JK flip-flop...
Hold. Let me open
Okay, sir.
Sir, in this slide, I have a doubt, sir.
Yeah, okay.
So, can you just go back to the previous slide once to show the circuit?
Okay.
No, sir, for the flip-flop.
From this slide.
Just one previous slide.
Okay, yeah.
Here we don't have an option to set S and R, right? We are not giving any input to S and R.
No, we can give, it has to be a 3 input and a gate here, R and S here. It is not.
So usually in flip-flop, do we have a clear and reset, sir?
Yeah, it will be there. Definitely it will be there. At least a reset will be there for sure. Okay, set may or may not be there in some ICs, but when we do VLSI design at transistor level, we ensure that both S and R are there. Okay.
Okay, sir.
We can just put it on these NAND gates, what you see. Okay, we can put, or inside inside the latch also there is a NAND gate, right? We can put an additional input there also.
Sir?
Yeah, tell me.
So the circuit that you showed with reset and clear,
yeah,
can you open that once?
Yeah, tell me.
So this is latch, right? D latch. D latch is written.
Yeah, it's D latch, correct.
Okay. So that S bar and R dash are preset and clear for D flip flops.
Yeah, that is for flip flop, but we are going to make a flip flop using a latch, right? A basic latch.
Yeah.
So we can incorporate these signals in the latch itself.
So S bar and R bar are preset and clear.
Correct.
For that.
Correct.
Okay. Thank you.
Okay. Okay. So everybody's clear with this. Then I'll open up the next presentation. Okay. Which was the presentation? Somebody had asked me.
Sir, lecture 17.
Who is speaking? I can't see.
Vraj, my name is Vraj, sir.
Right. Okay. Right. Lecture 17. Okay.
So, sir, in slide 4, in the JK flip-flop.
Yeah. Okay.
So, sir, can you explain what the meaning of the triangle for the clock input is?
Okay. Yeah. Okay. So, is there any doubts with this?
Sir, I have one more doubt. What if I put preset and clear both equal to 1? What would happen then?
That is not allowed, but if you do that, I think you will get Q and Q bar both as 1.
Okay.
Right? That could actually in a CMOS circuit, those things can create a lot of power dissipation in the other states where it is expected that there is no path between VDD and ground, but if you try to give both Q and Q bar in circumstances, the logics circuits might fail, and there could be also be some short circuits. So
Okay.
that's okay.
Okay. Thank you, sir.
Okay. Anybody else has got any doubt?
Sir,
Yeah.
can we say that latches are part of asynchronous sequential circuits?
Latches are part of sequential circuits also, because latch is modified to become a flip-flop, right?
Okay, so latch can be synchronous and asynchronous also.
Yeah, it can be synchronous and asynchronous also. For asynchronous also we use flip-flops. Only thing is, in an asynchronous, all the flip-flops are not given the same clock.
Okay, understood.
Correct. If you see, if you a frequency divider making T flip-flop, which is there in the tutorial also, where we have given JK, the output of first JK as a clock to the next stage. Okay.
Yes, sir.
And since the both don't have the same clock, they will be termed as asynchronous.
Yes, sir.
Okay.
So can you open the slides of the lecture 10 slides?
Lecture 10. Okay. Yeah, tell me.
So the optimization of multi-output circuits. That.
Okay. Yeah, tell me.
So the next slides. So two, three slides below. So then just here.
Yeah.
So the previous slide.
Yeah.
Sir, how are input nets here 4? 7 plus 4. Can you explain this?
Okay.
Input nets.
Here these are the 3. So so this is one gate, right? It has got 2 inputs.
Yes, sir.
Okay, and 1 gate here. Okay, what about here? This is going to be another gate.
Yeah.
Right.
3 inputs.
3 inputs, and then there is going to be one more this thing, OR gate also.
Yeah, with these 2 inputs. Yeah. So 7 input nets for this. So can you explain the 4 one? I wasn't understand.
Okay, here do we have to generate this signal?
Yes, sir.
No, it is there now. It's already there.
So I think the 1 is there, right? We would have to generate the above one.
Yeah, 1 is there. So the two input nets here and 1 gate here, right?
Yes, sir.
And one more,
Yes.
and this is already generated. So one more OR gate, right? One OR gate will be required.
Okay. So, sir, 2 inputs for the AND gate and 2 inputs for the OR gate that would be required.
Correct.
So here we got 4.
Correct.
But sir, there is another example in the same slide where we did not counted this input. The last one.
Okay. Can we go to that slide? Which slide, if you remember?
The last slide. In this slide, only the last slide. With the 3 functions. Yes, sir, the 3 one. Sir, here in F3,
Okay.
you written only 4 inputs.
I have written only 4 inputs. Is this coming from somewhere else? No.
No, sir.
This is being generated here itself.
Yes,
right?
sir. Yes, sir.
So 2 gates here.
Yeah.
Right? 2 gates
Yes,
here, and this is going to be 3 input, right? So it should be
Yes, sir.
5, right?
6 actually.
2 here and 3 for one
So you will get 3.
OR gate.
3.
3 input OR gate.
So there will be a 3 input AND gate also, right? There are 4 variables here.
No, these 2 variables are already being generated by these 2, right?
Yes, sir. But for the new one,
Yeah.
that will have 3 inputs, right? 3 input AND gate will be there.
Yeah. So 3 inputs plus 2 here. So 5. Right?
So there would be a 3 input AND gate and a 3 input OR gate, right?
No, why 3 input? Okay, this is 3 input, right? Yeah. Okay, yeah.
Yes, sir.
Correct.
So there will be 6 inputs here.
Yeah, correct. There will be 6
inputs.
6 input. Yeah. Anybody else has got? No.
Sir,
Yeah.
high impedance states default to 1.
High.
The high impedance states default to 1 in a TTL circuit, in a TTL gate.
Yeah, correct. Yeah.
So what's the reason for that?
In a TTL gate, I said if you don't give any input, if you leave it the wire like that, it will take it as an high impedance, right? So I can show you that. This I'll cover in the class towards the end. See, this is the input of it. Shall I maximize this? Okay, can you see this diagram?
Yes, sir.
Okay, so this is how a TTL gate is there. Okay, it's in a transistor logic. How this functions is, okay, this is the base of a transistor, right? And this is the emitter and this is the collector. Okay, so the base is already powered from VCC through a resistance. This is ready to conduct provided you give a ground to here, right? Okay, so whenever you provide a ground here, what happens is, okay, this will become a 0 out here, right? And then this transistor will be switched on. So switching on of this transistor, okay, it will try to take current away from Q2. It will try to sink current from Q2. So this will go off and this will go off. So this part we will leave it as such. We'll just focus on this, what is happening here. So essentially you have to give a, whenever you give a 0 out here, right, you are providing a ground and enabling this transistor to be switched on. Okay, so if you give a 1 here, so it is already 1 here and a 1 here, so there is no potential drop here, so it will be in a switched off condition. So that is why in this case, if you are not giving any input, okay, if you are not giving a 0 out here, we are not allowing current to flow here. That means this transistor will be in a off state, which is what happens when you give 1. When you give 1, this transistor is off because there is no potential here. It is 5 volt here. If you give 5 volt here, it will be 5 volt here. So this transistor will be in a off state. Whereas if you give a 0 volt here, this transistor, you see this arrow, so the current will flow like this. So if you give a 0 here, the current will flow here. If you don't give any connection, again the current will not flow. That is equivalent to a 1 here. Is it okay?
Yes, sir. Thank you.
You will get a vague idea right now, but towards the end of the class I will explain you. I'll have to cover a little bit basics about how this transistor functions. Then only you'll be able to understand the entire circuit. So I thought you are having microelectronics subject this semester? No. Are you having microelectronics?
Sir, I think next year we have microprocessing and interfacing. It's another course.
No, that doesn't deal with transistor level. It's a microprocessor and interfacing. It's a course on the microprocessors, right? So it will be another again 650 odd plus student course, and I don't know. I took few classes last semester, so. If they offer me again, then you will have to again jello me again for another 6 months, with all these things. Okay, but these operation of the transistors will be covered in microelectronics course. Do you have any electronic devices course or microelectronics course this semester? Okay, so for the computer science students, I'll just cover a little bit basics about these transistors, just to understand how these gates functions. That will be only towards the end of the course, because that will be kind of out of syllabus, but then still I will dedicate one class towards understanding of these circuits. Okay, it will be clear then. Okay, anybody else has got any other doubt? No?
Excuse me, sir.
Yeah, tell me.
Sir, can you explain how to find from the circuit whether it is positive edge triggered or negative edge triggered from the circuit?
From the...
Like, if you give a circuit, how we can say it is a positive edged or a negative edged triggered?
Okay. Master slave flip flop is pretty easy. I mean, you'll have to think over it, what is happening. I guess I won't be able to give you unless I get some example, then I can see. I never thought over it, so I'll have to think over it. Then only.
Sir, will it be mentioned in the question itself?
Yeah. In questions, you will not have any problems. Okay, as means T2 questions, it will be pretty simple what you have studied. Okay. Yeah. See, the aim of T1, T2, T3 is just to see that you have understood what you have been taught in the class. Okay. Whereas in a gate exam and all, okay, there the idea is to get the best out of the lot, right? Here I'm not trying to get the best out of the lot. Okay, here to the basic aim itself is different, that you once you finish this course, your fundamentals on digital should be cleared. So the questions are put at with that nothing, that's the intention of drafting questions when I do for it, that you should know once you have done the digital course, and when you go for a normal interview, you should be able to answer all the basic questions. So your understanding of the subject is more important. Okay, so I'm not trying to find out who is the best in the class or not. Okay, so the questions won't be that difficult. Okay, it will be basic questions like you had for T1. Here it will be a little more difficult because you have bigger circuit, so you'll have to think a little more, but again it is only basic concepts. Okay, I have to take on this question also, so shall I take on that now? Is there any other doubts?
Yes, sir. So it will be mentioned in the question that whether the circuit is positive edge triggered or negative edge triggered or level triggered.
Yeah, it will be there.
Okay.
Sir, I have a doubt and a question. Can I present my screen once?
Yeah. Who is this? Can I know the name?
Sir, Durba.
Pardon?
Durba.
Okay, Durva. Yeah. Okay, I have to stop presenting, right?
Sir, this was one question from one previous year paper.
Okay.
Here basically I think they have two D flip-flops connected. And we have to draw the output waveform. So here there's a bubble near preset and clear, but they have not put preset bar and clear bar. But we should assume that this is complement only, no, sir?
Yeah, correct.
Okay, sir. So here, like logic 1 is given, so preset will basically take it as 0.
It is disabled, you can say.
Yeah. Okay, sir. Fine. And based on this X output, first we will draw output of this Q and then take it as a D for this and then draw the output waveform.
Yeah, correct. So essentially, whenever X is going 0, the output will go to 1 irrespective of the clock.
Yes, sir.
Okay. The first flip-flop.
Yes, sir.
Okay. Whereas the final output will depend on clock. The intermediate output will go to 1. Right?
Yes, sir. So
we will discuss the solution here, no problem. Let's see what happens. Okay. During the positive edge of the clock, okay, X is high, right?
Yes. Yes, sir.
X is high, right? So it will take where will it take the input from now? It will take from D.
Yes, sir.
Okay, D is taken, so the output will be low initially.
Yes, sir. Logic 0.
So low. And then the preset X is going low.
Yes, sir. So preset value is 0.
Okay, so the output will go to 0. Preset, right? So it has to go. It will continue 0. Right?
Yes, sir.
No, it will go to 1.
No, wait.
It will go to 1.
Here it is 0.
Yeah.
And
it will go to
clear
1.
So it will go to 1.
It will go to 1 there. Okay. And then X is again going back to 1. Right?
Yes, sir.
But then it is both preset and clear are 1. That means it will continue in that state. It will
continue the previous state.
It will continue to remain in 1. Right?
Yes.
Right? And then then it will again X is making one more transition. Doesn't matter. It will continue to remain 1.
Yes, sir.
When the next clock comes, right, it will again take the D input, which is 0, and it will go 0 here. When the next clock comes, during this positive edge of the clock, right? So the preset input is removed, so it will go to 0.
Yes, sir.
Right? It will go to 0. So that is how you will keep constructing the waveform.
Okay, and after getting D for the Q from here, then we have to take that Q as the D for the second one and then make the final one.
Yeah. So that transition, what happened in between, will not get reflected at the output, right?
Yes, sir. The output will be based on the output of the first one.
When the clock was going high, what was the output first here? It was 0, right? So it will continue to remain 0 here. So whatever has happened in output of the first flip-flop doesn't get reflected here. So this will continue to be 0 throughout.
Yes, sir.
Correct? So that's how we'll have to slowly construct the waveform.
Okay, sir.
Is it okay? Okay.
Yes, sir.
Okay.
I just had a doubt in the convention because they have kept the bubbles here and
Okay.
it was.
Okay. Okay.
Thank you, sir.
Okay. If you stop presenting, I'll just flash this circuit which somebody had a doubt. Yeah.
Yes.
Okay. This question, right? So it is a clear bar here, clock here, D here, Q and Q bar, right? So
Also, we can't see your screen. I mean, you're not presenting.
oh sorry. Yeah. So this was from previous, somebody had mailed me. So what is the problem here? It's all pretty simple circuits, right? Here there is no clear given, so you can assume that this is working just like a normal flip-flop. So whenever the positive edge of the clock, right, so it will follow D. Here there is a clear also, right? It is given clear bar. That means whenever the clear is it is 0, right, it will be reset to 0, and then subsequently this is enabled throughout. So it will be whatever is the D, it will follow that only during this phase, clear bar, right? When clear bar is 0 out here, it will be cleared, so that it will be 0 here. So is this question clear to all of you?
Sir?
Yeah, tell me.
Sir, the second one we should take it as a latch, no sir, because it is given EN.
Yeah, correct. Sorry, I missed it out. The second one is a latch. Okay, second one is a latch, and if you see there is no triangle given here, so this is a latch. So whenever the clock is high, right, during that phase, whatever is the change happening in D will be reflected here. So you see in this case, so the D is making a transition like this, so that will get reflected at the output, right? Here also during the clock high there is a transition which will get reflected here also. So that is the difference between these two outputs. Is it okay?
So can we conclude that latch is a level triggered and flip-flop is edge triggered?
Yeah, you can do that. You can take it that way.
Okay.
Right. So that, and somebody okay, they wanted the second one also, I guess, and this one also. So here you have A, B, and then carry in, which is coming from here, right? A, B. So initially it is an A, B, then you will have to make one more diagram out here in the below to understand how this is going to work. So this will be AB, and whenever the clock is going high, so D will change, right? Whatever is the D will be captured here. Q, that is given as C in. So accordingly you'll have to make one more output out here which will enable you to or directly Q based on the clock. So whenever the clock is going high, you have to see is there any carry. If there is a carry, Q will be high. If there is no carry, Q will be low. So you keep constructing this waveform out here. Is there any doubt in this circuit? Anybody? Is it clear? I mean, it only appears complex. If you just think it clearly, it is pretty simple circuit only. There's no doubt in this. Is both of these diagrams clear? Right? Who mailed me? I think Sheikh mailed me, right? Yeah. Okay. So what is the initial input for D? So there might be something here. It's written here. Consider Q and S are initially in reset. That means it is in 0. So that condition is given here already in the question paper itself. Is it okay? So if there are no more questions, we'll call it off for today, and prepare well, and let's see.
Excuse me, sir.
Yeah, tell me.
Can you once again explain, sir, lecture 16th graph, sir, because that S bar, why it is influencing over D?
Okay. See, you are giving it here preset, right?
Yes, sir. Yes,
so
sir.
if you give a 0 here, what happens? Straight away this is an AND gate, you will get a 1 here. Preset is set.
Okay.
Right? Preset bar is set bar. So if you set bar, if you are giving 0 here, straight away you get a 1 here. It doesn't depend on what inputs you are giving, right?
Yes.
You are giving it now in this. Similarly clear, right? If you give a 0 out here, right, Q bar will become 1 here, that 1 will come here, and it will, since preset is already 1 here, this will be 1, so it will be set to 0 irrespective of what happens.
Okay.
Irrespective of D and input and enable, right?
Okay.
Okay.
Sir,
Yeah, tell me.
can you open slides of lecture 9? Yes. Slide number 53.
Okay. Slide number
53.
53. Okay.
Sir, actually,
Yeah, yeah, tell me.
sir, after this, this is 52.
Yeah, tell me.
Sir, actually, I'm getting confused here. Is B an essential prime implicant or not? So if you'll press, can you go a little forward? It will show the final expression. Yes, sir, here. Sir, is here B is essential prime implicant or not?
Actually, it is because it is dominating here. Okay, we are taking it as a prime implicant for this particular solution, but I know it is a bit confusing because it has got two minterms, but it's a prime implicant. You can take it that way.
So if in a question it is asked to give essential prime implicant using 2M method, so whatever we will get in the previous step, only those will be the essential prime implicants. Like whatever we get in the step 2.
Here on the left hand side.
No, sir. There is a previous step 2, right? When we get essential prime here.
Here.
So only D and F are only the essential prime implicants here.
No, B is also will become an essential prime implicant.
Okay, so sir, how?
Yeah, the final when we say essential prime implicants, okay, that means they are essentially required, without which the function cannot be complete. So even B has to be included there.
So B will be essential prime implicant here for this particular question.
Yeah, correct. No, what is did we say essential prime implicants? No, we are trying. This slide heading says ki essential prime implicants, right?
Yes, sir.
We say ki okay, these will be definitely be part of the solution. Okay, we
Okay.
are finally, we have not yet finished this essential prime implicant solution, right? So this is just a partial solution. If you see D plus F. Okay, this is the
Okay.
final solution. So obviously in the final solution even B is included.
So B will be essential prime
Yeah,
implicant.
B will be essential prime implicant.
Okay. Okay. So in a full adder, if we'll be implementing it using two half adders,
Yeah.
the carry delay will be 3.
Yeah, correct.
So in ripple carry adder, when we use 4 full adders.
Yeah.
So there we use implement the full adder using two half adders, or it can be anything.
No, that will be specified in the question. That depends on.
So it will be specified.
Yeah.
So it will be specified if it is implemented using half adders or not.
Yeah, correct.
That will decide the delay. Okay.
Yeah.
Can you explain column dominance once in QM?
Actually, this column dominance is, we already did that here. That,
Previously.
yeah, previously here.
Actually, I was getting confused between this and that particular slide.
No, we already did that here.
So this is column dominance,
Yeah,
what
this
we
is
did.
column definitely.
So 9 here, dominates over 0 and 0, 1 and 8.
Correct.
Yeah, okay. Thank you, sir.
Okay. Anybody else? That's all. So
Sir, I have a doubt in the Tute 7, net tutorial 7, yes, sir.
yeah, okay. Which is the slide?
Sir, in the 5th question, sir.
Yeah.
Is it a negative? Is it a negative edge triggered, or is it a positive edge triggered over here? Because there's like a circle over there for the clock, right? So
Yeah, it's a negative edge triggered. If you put a circle out here, it means it's a negative edge triggered. Right? This is the notation. Whenever there is it's a clock and a negative edge triggered, we put a circle there.
Yeah, got it, sir.
Okay.
Sir, excuse me, you have solved that question using positive edge trigger, sir.
Which one?
This 5th question of tutorial 7. Fifth question.
Okay, the solution is not given here. Okay, I think this
the video. Sir.
Okay, doesn't matter. It will still come the same. I might have missed out. So even if you do that, it will give the same.
So, sir, if there's only triangle, then it's a positive edge. If it is triangle plus a knot, then it's negative edge. Sir.
Correct.
Okay, sir, got it.
Yeah, tell me, somebody else had some doubt.
Sir, I have a doubt in the question paper. So,
Sir, here the triangle symbolizes the clock, right?
Yeah.
The positive edge or negative edge will get from the circle it has there.
Correct.
If it doesn't have the circle, it is positive edge. If it does have the circle, it is negative edge.
Correct.
Yeah, okay. Thank you, sir.
Yeah. You want to somebody wants to present something? Okay. Yeah, go ahead. You can present your question.
Yes, sir. Sir, can you once discuss the second question?
Yeah. Okay. Tell me.
So this one.
Which of the following sequence is generated at Q output of figure 2?
Yes, this figure.
Okay. So okay, what is the initial condition? Assume both flip-flops are initially 0, right? Okay, so this is 0, this is 0 out here, right? Okay.
Yeah, the Q and output are 0 initially.
Okay. So what is the sequence? So where is the sequence taken from? From the JK flip-flop, right? Output. Okay. So during the first clock, okay, when is the first clock? Output of D is 0, right? And so that is given to J and K, 0 0.
Yeah.
So the output will remain 0.
Yeah. So Q dash will be 1.
Q dash will be 1, that will be given to the D input, right? So that will the Q from the D flip flop will go to 1 state.
Yeah.
Right. So in the first clock, the output will remain 0. The output, right? Okay. When the next clock comes, right? When the next clock comes, again, what happens is our Q will get flipped to 1. It is toggle. It is toggle. Whereas Q bar, it will take when the clock is coming, it was initially at 1, so this will again continue to remain 1.
Yeah.
Okay. You have to you will not take that next state to feed it to D.
So when Q toggles, won't Q bar also toggle?
Q bar will toggle, but even before toggling, the input will be fed to the previous state. There will be certain propagation delay kind of thing here, right?
So it will be first fed and then toggled.
Pardon?
So it will be first fed with the previous state.
Yeah. Because there will be some time lag for Q dash to change, right? But meanwhile, whatever was the previous state available, this D flip flop will take that, so it will continue to remain 1 there.
Okay.
Right. So you will have to analyze that circuit in that aspect. Again, when the clock comes, the next clock comes, Q bar will, since it is 1 out here, it will again toggle once more. But this time, it will be taken as an 0. What was it? It was 0. So that will be taken and it will be 0 out here. So that is how you will construct the sequence.
Okay.
Right?
Thank you.
Okay. So for these circuits, you have to be you have to consider the small propagation delay. So what was the previous state? That will be taken as the input for these flip flops. Yeah. Others, you stay inside the campus, is it?
Yes, sir.
Okay. Adarsh, I am your mentor also, is it? Did you?
Yeah, like previous, like I was in EC, that time you were assigned.
Okay.
Now I got transferred to CS.
Okay. But then we didn't get an opportunity to meet and discuss. Last semester also was online or something like that. I don't know. Okay.
Yeah, half of the semester.
Yeah. Okay.
Yes.
Okay. Anybody else has got any queries? No? Okay. So then we'll call it off today. I'll record this and share it with other students also. And don't worry about I am not going to put very difficult questions out here. So because I'm not preparing you all for GATE or something, so I want you to just to understand the concepts of digital design, that's all. Okay. And nevertheless, I'll share, if I get some material on GATE and all, I'll share the questions with you all, and those who are interested may solve that, and if there is any doubt in that, I'll be able to help you out separately. Okay. So thanks a lot for today. So, and all the best for your exam on Saturday.